somewhere we have completed this atmosphere in all sense, right? After completing atmosphere, what we are going to do is very simple, right? We are going to take or talk about the individual component of this climatology, what we have seen in yesterday's class. Okay, right? What is that? Somewhere we found a forward linkage, right? See, even in your books, NCRT books, whatever books you take it as a source material, right? These are the different topics that will be discussed, right? So what I'll do, right? So I'll start with insolation. This will be my order, my friend. We'll understand what is insolation, correct? After talking about insolation, I'll be talking about atmospheric temperature, pressure, and so on. Okay, right. So first, I'll start with insolation, my friend. Right. Insolation. Okay. See, what is insolation? If you ask me, insolation itself is an abbreviation, right? A kind of an abbreviation which stands for what? Incoming solar radiation. Right? It is nothing but what? Incoming solar radiation. Or if you're a layman, my friend, if you're a layman, right, this incoming solar radiation, right, you can also call it as what? Solar energy, my friend. You call them as what? Solar energy. Simple, right? The energy that comes from the sun, you call them as what? Insolation. You simply call them as what? Incoming solar energy, solar radiation, or you call them as what? Solar energy itself. Okay. Now, some basic definition you can take it. Okay. Basic definition you can take it. The trace amount of heat. The trace amount of heat received by Earth. Trace amount of heat received by Earth from the sun is called as insolation. I repeat again, I said trace amount of heat received by Earth from the sun is called as insolation. Is called as insolation. Okay. So what is insolation? Approximately we have an idea, right? I said, see, not the entire energy that comes from the sun, the trace amount of energy, trace amount of heat that Earth as a system receives, you call them as what? Insolation. That's it. Okay, only the trace amount of heat comes to Earth. Okay. Now, my dear friends, almost this insolation amount is static throughout the year, my friend. What Earth as a system receives. Only thing is that distribution of insolation will differ from place to place. Am I right? But what Earth as a system receives is almost static throughout the year. Okay, right. Now, that also you can write it. You can write it, right? The amount of insolation received by Earth is almost static throughout the year. Is almost static throughout the year. Barring the exception of perihelion and aphelion, my friend. Barring the exception of perihelion and aphelion. Now you may wonder, right? What do you mean by this perihelion, my friend? Right? What do you mean by this perihelion? Any idea? What is this perihelion? And what is this aphelion, my friend? Somewhere I told you The amount of insolation received by Earth as a system, see, amount of heat. Assume that this is Earth, my friend. This is Earth. Am I right? The amount of heat received by Earth is almost static throughout the year. But barring the exception of perihelion and aphelion, right? What is this perihelion and what is this aphelion, my friend? Right, very good. Perihelion is what? Closest distance of Earth with respect to what? Sun, my dear friends. All right. So when I talk about somewhere, when I talk about perihelion position, right? What you will experience is what? Higher insolation, marginally higher insolation. And as you know, this is the closest distance what Earth as a system experience. Am I right? Somewhere I'll tell you, the distance will be somewhere around 147 million kilometers, my friend. On the other hand, when I talk about aphelion, slightly this insolation will be received, means insolation will be lesser. Insolation will be lesser. Am I right? What you will experience is somewhere around 152 million kilometer of insolation, sorry, of distance you will be experiencing. So between this perihelion and aphelion itself, you have the difference in the distance of 5 million kilometers, my friend. See, 5 million kilometers is beyond imagination. Am I right? 5 million kilometers, right? And any idea, my friend, when exactly you experience this perihelion and aphelion, date-wise? Very important, my friend, right? I'll also copy this date, very, very important, right? So what do you experience, say, for example, right? We talk about perihelion, right? It happens on, very good, January 3rd, and aphelion happens on July 4th or July 3rd, my friend. Okay, very, very important. It happens on July 3rd or it happens on July 4th. It depends. Okay. So somewhere I told you that insolation is almost going to be static, but barring this exception, what is this exception? Apart means approximately V, right? Perihelion you're going to experience on January 3rd, and aphelion we experience on July 3rd, July 4th. Right, slightly 1 or 2 days it can come before or come after, it doesn't matter. Okay, right, my friends. So we have an idea. Now, my dear friends, slightly I would like to deviate. I'll ask you a question, right? We'll only discuss, we'll not even, okay, we'll not take it very seriously, only about discussion, my friend. See, you heard about Australia, right? Australia. If you have the map of Australia, my friend, assume that you are there sitting in the class with the atlas. Okay, you have atlas in your hand, right? Or simply you take the map of Australia. Okay, I'll also take the map of Australia. Right. If I just talk about Australia, you find a few things very unique in Australia, right? You yourself can tell me, my friend, what is so unique about Australian cities, my friend? Generally, when I talk about Australian cities, what is so unique about Australian cities? Christmas in summer accepted, not only Australia, even New Zealand, Argentina, Chile, South Africa, am I right? All these countries experience, right, they celebrate Christmas during summers, my friend. Okay. Even I talk about countries like Zambia, Namibia, right? All these countries, right? Lesotho, Swaziland, all these countries, they celebrate Christmas during summer. Cities are mostly by the coast. That's it. Very good, fantastic observation. My dear friends, if I just talk about Australia, right? I understand, right? It means whenever I talk about the cities of Australia, my friend, what I understand, the cities of Australia are congested along this, right? Say, for example, the coastline. Right? Hardly you will be having a city in the interiors. Only you will be finding the province But see, every city you take it, right? These cities are located along the coastline, right? See, all the cities, my friend, you take all these cities, they are located along the coastline, my friend. Every city, right? Every city, right? Hardly you have a city, only two cities you have interiors, my friend. Otherwise, I understand, okay, Kalburli is for a different reason, right? There also you have one Kalburli, my friend. Okay, right. So not only in Assam you have this Kalburli, okay. Yours is Karburli, right? Okay. So what you have in Australia is what? Kalburli. Okay. Kalburli is different, right? This is all for the gold what you find here. We have the settlement, my friend. Otherwise, every settlement you take it, all these settlements are there in the coastal region. Every settlement, what you find, it is in the coastal region. Only two or three settlement is an exception, my friend. Okay. Now comes the question, why? Okay, why I'll tell you. Number one, see, not only here, any place where the settlement has taken place. Just a minute. Just a minute. Right. So I was just talking about Australia. Australia, all the cities are there in the coastal regions. And one of the reasons why Australian cities are there in the coastal regions, if you ask me, let me tell you, Australian summers are very, very harsh, my friend. Then you may ask, then why only people settled in coastal area? Because I understand coastal areas, water maintains the temperature. The difference in temperature between summer and winter is not so great, my friend. Okay, somewhere the difference is not so great because water has the ability to maintain temperature. Has the ability to maintain temperature. That's the reason the temperature difference is not so great. And one more thing, let me tell you, all this newly discovered region or newly discovered land, right? The settlement has taken place only in the coastal regions because this is the place where normally the people come, right? Say, for example, ship is the commonest mode of transportation, which has transferred the people from continents to continents. Am I right? I'm talking about the post age of discovery. Okay. So what happened there, right? Say, for example, there I can understand. It means people got down at the coastal region. They started settling in the coastal region. Even Americas, North America and South America, you take it. Most of the human settlement would have taken place in what coastal areas, right? But only thing is that as the time advances, people will also start advancing towards the interiors, correct? But Australia, this did not happen. People did not move inland, correct? Why? Again, let me tell you, Australian summers are very harsh. Particularly if you're there in interiors of Australia, my friend, I understand summers will be very, very harsh. Every year, my friend, every year, Australian summers are known for its forest fire. Correct? In Australian parlance, you call them as what? Bushfires, my friend. You call them as what? Bushfire. You call them as bushfire, right? Australians summers, every year what you have is a bushfire, my friend. Okay. What is bushfire? Forest fire. What you call them as a forest fire, Australia call them as a bushfire. Right? Every summers of Australia it is known for bushfires, my friend. Now I have given you a number of ideas, right? Why human settlement has happened only in the coastal regions. Why Australian summers are very harsh. Why bushfire occurs almost every summers of Australia. Almost answer is more or less related to each other, my friend. Now I'm just asking you a question. What can be the potential reason for Australian summers to be that harsh? Any idea, my friend? Summers of Australia is very harsh. And one more thing. Every deviation is relevant to the topic what I'm taking. Am I right? Now comes the question, my friend. Why Australian summers are that much harsh? Any idea? Again, let me tell you, see, coastal regions, if you're there in the coastal regions, right, the difference between summer and winter is not so great. Fantastic, I got the answer. Right, it means Australia, my friend, particularly when I talk about Australian summers, right, Australian summers, two phenomena coexist together. So if you're there in Australia, particularly when I talk about January, my friend, right, Australia, right, I talk about Australia, during the month of December, January, right? What exactly Australia is going to experience? Two phenomena coexisting together. Number one, it is going to experience the peak summer, correct? The peak summer of Australia is somewhere around December 22nd, my friend. Okay. Along with this peak summer, Australia is also going to experience what? Perihelion, right? Australia is going to experience what? Perihelion. So when exactly you're going to experience perihelion? January 3rd, my friend. So what happens? What is the idea? Already it is summer. Along with this summer, sun is also very close to Australia. So the insolation amount is going to be on a higher side. Correct? So what happens? The temperature becomes very, very high. And not why not the other countries of southern hemisphere, if you ask me? Most of the other countries of southern hemisphere, the size is comparatively smaller, and they have the influence of the ocean on them. Australia being the larger continent, and Australia has a very vast desert, my friend. So that's the one which makes a life horrible in what Australia during summers. Coastal areas, somewhere you can manage, but continental interiors you cannot manage. Okay, right. So why? Two phenomena coexist together. Summers plus perihelion condition. Correct? That's the reason Australian summers are very, very harsh. Okay, right. So what is insolation? How this insolation is going to differ from time to time, that also we have taken it. Almost I said it is uniform, barring the exception of perihelion and aphelion. And what is the effect of perihelion in Australian climate, that also we have taken it. Okay, right, my friends. Now, somewhere I have to talk about the distribution of this insolation, my friend, right? Earth as a system receives more or less similar insolation, no denial about it. But now, let me talk about the distribution of insolation, how this insolation varies from place to place. So I talk about distribution of insolation, my friend, right? How this insolation is going to vary from place to place. Okay. Now, my dear friends, what are the factors which affects the distribution of insolation? Though insolation is almost static throughout the year, barring the exception of perihelion and aphelion, the distribution of insolation will significantly vary from place to place. What are the factors for such distribution and the variation, if you ask me, my friend? I would say, number one, it is angle of sun's rays, my friend. Angle of sun's rays. sun's rays. I'll explain it. First I'll write it, then I'll explain it. Number 2. Distance traveled by sun's rays. Distance traveled by sun's rays. Traveled by sun's rays through atmosphere. This sentence, the second sentence, what I have just given you a factor, very important factor, I'll explain it. Distance traveled by sun's rays through atmosphere. Number 3, seasons, right? Or the seasons, either you call them as seasons or simply you call them as what? Length of day, my friend. You call them as what? Length of day. Okay. So angle of sun's rays, distance traveled by sun's rays through atmosphere, seasons or length of day. Okay. See, okay, one by one I'll explain it. Okay. Number 1, my friend, the most important. See, for example, I said entire Earth as a system, insolation received is almost static. But from place to place and time to time, there is a major variation in it. Okay. That's the reason I said the number 1, the most important factor among everything. That's factor number 1. I call them as what? Angle of sun's rays. Call them as what? Angle of sun's rays, my friend. Okay. What is this angle of sun's rays? Simple, my friend. At what angle the sun is falling, right? That's what you call them as what? Angle of sun's rays, my friend. See, for example, assume, right, I'm just talking about one place, my friend, one place, right place. Let it be our own place, my friend. Okay. See, for example, sun is rising, correct? Sun is rising, right? Sun has reached the maximum height in the sky. Okay. And now the sun is setting. Okay. And sun is somewhere placed between this rising position and setting position, somewhere, my friend. Okay. Assume that this is how the sun is moving, my friend. Right? Sun is moving. Correct? Sun is moving. Right? Now, my dear friends, approximately, if you ask me, right, what angle, right, when the high sun position will be falling, somewhere around 90 degree, my friend. Correct? When I talk about the low sun position, when you ask me that what angle it will be falling, right, somewhere. If you ask me what exactly is the angle that will be falling, right, let me tell you, this angle will be somewhere around 45 degree. Okay, this will be 45 degree. Okay. When I talk about the rising sun and setting sun, it will be somewhere around 0 degree. Am I right? So what you have is what? Somewhere around, let me write it here itself, 0 degree, 45 degree, and 90 degree. Again, it reduced to 45 degree and 0 degree, my friend. So what I understand, whenever I talk about sun's rays falling, sun's rays can fall at any angle between 0 degree and 90 degree, my friend. 90 is the maximum angle at which the sun's rays can fall. 0 is the minimum angle at which the sun's rays can fall. Sun, you can find it, right? Rising sun and setting sun, you call them as what? Sun's rays, right? 0 degree. So this is what I call them as what? Angle of sun's rays. What angle the sun's rays is falling. So in that regard, what I'll do, I just classify this falling of sun's rays into 2 categories, my friend. 2 categories. One is high sun position and low sun position. Okay. Let me call it as what? High sun position and low sun position, my friend. Say, for example, at one place, say, for example, let me call it as what? High sun position. The sun's rays falling at the highest possible position. Right, falling at the highest possible position, my friend, sun's rays. Right, another place, my friend, the sun's rays is falling at the slanting angle. Sun's rays falling at the slanting angle, my friend. Okay, some low sun position. Okay, somewhere it is falling at the slanting angle, my friend. That's it. Okay, So one, sun's rays falling at the highest possible position, right? Somewhere what I have is a slanting sun's rays. Okay. So just for binary classification, what I'll write it as what? High sun position. High sun position and a low sun position. Right? I call them as what? High sun position and low sun position. So what is this high sun position, if you ask me, my friend? High sun position is that position of sun, say for example, just for our own understanding, any angle that it is between 45 degree to 90 degree, let me call them as what? High sun position. So any angle, right, that falls between, say for example, right, 0 degree to 45 degree, my friend. Let me call them as what? Low sun position, my friend. Okay, so what is high sun position and low sun position? Approximately we have an idea. Okay. Now, my dear friends, assume that this is the surface of the earth. Now you find a major, say for example, factor, right? What I am just, say for example, trying to bring it here. Both these rays, the radius of this rays is same, my friend. The energy carried by both these rays are same, right? Both the rays, they have equal energy that is being carried, correct? The radius of this rays, they are similar, correct? But what happens here? What makes the difference? I'll tell you. The difference is all with what? The distribution, correct? At one place, what I find, this energy is getting concentrated, my friend. Energy is getting concentrated. Okay. At one place, let me write it. High sun position, energy is concentrated. Right, my friend. On the other hand, when I talk about low sun position, what happens? See, here the low sun position, the same rays, but if I just talk about the place where exactly it is getting distributed, it is getting distributed in a larger area. So what happens, my friend? Here the energy is getting distributed. Energy is distributed. Right? So one place energy is concentrated, one place energy is distributed. My dear friends, idea is very simple. Wherever energy is concentrated, what will be the temperature? Simple, right? See, we used to do one very naughty experiment, right? Normally, I used to do, right? If at all, if people are, say, for example, right, sleeping after a very long time, even if the hot sun, right? People normally will be almost, right, they'll be sleeping outside, right, my friend? They'll be taking some rest. Okay. What we used to do, normally we used to concentrate this. We used to take a lens, my friend. We used to take a lens, right? We will concentrate this, right? Sun's energy, we'll make it as a very bright, right, hot spot, my friend. So what happens normally is even you can burn the paper using it, right? You call them as a lens experiment, right? So whenever this energy is concentrated, my friend, temperature becomes very, very high, correct? And that's the reason, high sun position, why exactly you experience a very high temperature, if you ask me, because here the energy is getting concentrated. Slanting sun's rays, why the temperature is not so great, if you ask me, the energy is distributed over a larger area. This is the ultimate reason why temperature is different, takes place between different places and different seasons, my friend. Okay, it's all about angle of sun's rays. Right. Now, where all you can apply this concept, I'll tell you, my friend. Throughout the year, my friend, what you experience, say for example, when I talk about lower latitudes, when I talk about latitudinally, right, when I talk about latitudes, my friend, latitudes, throughout the year, my friend, lower latitude experience this high sun position, whereas higher latitude experience this low sun position, my friend. Higher latitudes experience that low sun position. Okay. So that's the reason lower latitude is always warmer and higher latitude is always colder. See, for example, you know the fact you cannot experience a sun's vertical rays beyond the Tropic of Cancer and Capricorn. Tropic of Cancer is the northernmost limit where sun's vertical rays can be experienced, 90 degree. That's the reason normally we say, right, Delhi, places like Delhi, never in their life would have seen what sun's vertical rays. Right, because I understand Delhi is located what? North of Tropic of Cancer. Correct. So somewhere I understand, my friend, as you move away from this Tropic of Cancer, right, or Capricorn, right, what you experience throughout the year is only slanting sun rays, my friend. Okay. So that's the reason lower latitudes are always warmer and higher latitudes are always colder. Okay. So latitudinally, I can apply this concept. My dear friends, you can also apply the same concept between seasons, my friend. Seasons. See, for example, I tell you, where is Bhopal, right, my friend? Bhopal. Bhopal. Right? Or let me bring this name called as my friend, Udaipur. Okay? Udaipur. Any idea where is this Udaipur, my friend? Udaipur. Rajasthan. Will you accept if I say this Udaipur is there in Tripura? My dear friends, there is also one Udaipur in Tripura which is very, very important as a location, my friend. I'll tell you because why. I don't deny the fact that Udaipur is there in Rajasthan, but there is also one Udaipur in Tripura, my friend. Tripura. My dear friends, this Udaipur is located very, very close to Tropic of Cancer. Close to Tropic of Cancer. Right? What is the significance of this Tropic of Cancer, you know? Am I right? Right? It passes. Tropic of Cancer passes through this Udaipur and Tripura, my friend. Okay. Very good. Fantastic. Right. Now, someday, okay, I'm just taking Udaipur itself. Udaipur itself. Right? Or I can take it Bhopal. So, what I want to tell you, either you consider Udaipur, right, of Tripura, Udaipur of Tripura, or you may consider Bhopal, right, of MP, my friend. Okay. Now, my dear friends, somewhere I understand, right, Bhopal or Udaipur during June 21. June 21st, it's going to be very, very warm. It's going to be very hot. But the same place, during December 22nd, it is going to be cold, my friend. Am I right? Any reason why? You tell me what exactly is the reason for it. Right? What can be the potential reason, my friend? Of course, I am talking about what? And it's not equinox. June 21st is solstice. June 21st is solstice, my friend. We call them as what? Summer solstice. Equinox is on March and September. March 21st and September 23rd, you call them as what? Equinox. Okay, right. You call them as what? Solstice. Right. My dear friends, when I talk about June 21st, what is so significant about June 21st? June 21st, very good. Sun's direct rays or vertical rays falls over what? Equator. Sorry, excuse me. Tropic of Cancer. It falls over Tropic of Cancer, my friend. Okay. So as the case, I understand what you're going to experience on this day is going to be, right? Say, for example, the vertical sun's rays, and it is going to be very hot. And that's the reason, my friend, not only summer, solstice, entire summer, right? Generally, places will experience what? High sun position. That is one of the reasons why exactly, right? You have a very high temperature. But what happens during winters? Right? Most of the places during winters will experience what? Low sun position. Right? That's the reason. Winters are comparatively colder. Same place. When I talk about Bhopal, my friend, Bhopal, you ask me what is the maximum height the sun can climb in the skies of Bhopal during December 22nd. The maximum degree itself is only 43 degree. But the same Bhopal on June 21st, it is 90 degree, my friends. See the difference. I'm talking about the maximum height, right? It is June 21st, it is 90 degree. December 22nd, it is only 43 degree. So one place, right, the maximum height, another place, right? I understand the minimum height. I understand. Again, what makes the difference is what? Angle of sun's rays. Why summer is warmer, why winter is colder, this is the reason. Correct? Right, my friends. Okay, right. So latitudes also we have discussed, season also we have discussed. My dear friends, why to take it? Let me talk about the same day, my friend. Sunrise. Sun is rising, right? And just now we have said, right? Somewhere we talked about this angle of sun's rays, my friend. See, when I talk about times, normally, my friend, assume that I'm just talking about some equinox day. Sunrise will happen at 6 a.m. Sunset will happen at 6 p.m. Right, noon will happen at 12 p.m. Exactly between, right, noon and sunrise, 9 a.m. right, and 3 p.m. in the evening, my friend. Right. So 9 a.m. the sun will make an angle of 45 degree. 3 p.m. again it will make an angle of 45 degree. My dear friends, why 9 a.m. to 3 p.m. is hot? Because of high sun position. Why morning and evening it is not so hot? Because of low sun position. This is another reason, my friend. Very important. Okay. So not only between seasons and latitude you can apply this logic, you can also apply the logic in a same day, my friend. Right? Why noon is so hot? Because of high sun position. Why morning and evening is not so hot? Because of low sun position. Right? This understanding is ultimate and very, very important. Okay? Angle of sun's rays, very important, my friend. Right? This is the basis for entire chapter called as climatology. Angle of sun's rays. Right? I think so far you're clear. You're clear so far. Okay. Right. Now we have to discuss about the factor number 2. What is factor number 2? Right, distance traveled by sun's rays through atmosphere. Okay, equally important. Number 2, distance traveled by sun's rays through atmosphere. This word through is very important, my friend. Distance of sun's rays traveled through atmosphere, my friend. The word through is very important. I'm not simply talking about the distance of sun's rays traveled. I'm simply talking about the distance of sun's rays traveled through atmosphere. So what I'll do, I just try to reuse the same diagram, my friend. Okay. Now, my friends, when I talk about surface, okay, assume that this is a surface over there. Now, what I understand, somewhere let me bring this atmosphere here. Okay, somewhere. Assume that this is atmosphere. Okay. From the surface, I'm just extending this atmosphere. Okay. Right, my friend. So let me talk about right this complete right. This is where right, assuming that you have atmosphere. Okay. What you have is atmosphere. Right. My dear friends, what happens? Somewhere I told you, right? It means Distance traveled through atmosphere is also very important. Now, when I talk about high sun position or vertical sun's rays, my friend, somewhere when I talk about the distance traveled by them, right, what I understand, they travel a minimum distance, my friend, right? They travel a less distance, right? They travel a less distance through atmosphere. On the other hand, when I talk about a slanting sun's rays, my friend, idea says slanting sun's rays travel a longer distance through atmosphere. Now, what difference it is going to make if you ask me, my dear friends? Longer is the distance traveled by sun's rays through atmosphere, more will be the loss of insolation. Right? Say, for example, when I talk about water vapor, water vapor present in atmosphere will absorb insolation, right? Water vapor absorb insolation, my friend. Okay. Similarly, when I talk about clouds, clouds can reflect insolation, right? Aerosols will scatter insolation. Whatever be the case, my friend, more is the distance traveled by sun's rays through atmosphere, more will be the loss. Okay. Lesser distance it's travel, less will be the loss, my friend. Okay. That's the reason I said more is the water vapor it will encounter, more aerosols it will encounter, more cloud cover it will encounter. Am I right? So the ultimate energy what reaches the surface of the earth itself will be very less, my friend. So slanting sun's rays, right? By the time it reaches the surface of the earth, it will be left with no energy, my friend. Most of the time, right? It will be an example of a faint rays, my friend. Am I right? It will have more energy, right? When I talk about high sun position, right, will have more energy on reaching the surface of the earth, right? On the other hand, when I talk about the slanting sun's rays, it will be a faint rays, my friend. It will be a faint rays. By the time it reaches the surface of the earth, it will be hardly devoid of any energy. Okay, so both the factors you have to take it together. Okay, so somewhere you can write it, my friend, as a sentence. You can write it. Very important, very very important. The distance traveled by sun's rays through atmosphere. Very important. You can write it. Vertical sun's rays. Vertical sun rays. Vertical sun's rays. Travel a minimum distance. See, when I say vertical sun's rays, what is the meaning of vertical sun's rays? Right? The sun's rays which is falling at 90-degree angle, I call them as what? Vertical sun rays. Vertical sun rays is the one which will be, say, for example, falling at the minimum angle. Okay. Sorry. Which will be traveling the minimum distance. You can write it. Vertical sun's rays travel a minimum distance. Travel a minimum distance through atmosphere. Through atmosphere. Whereas a slanting sun's rays travel a longer distance through atmosphere. Travel a longer distance through atmosphere. Right. Further you can write. More is the distance traveled by sun's rays. More is the distance traveled by sun's rays through atmosphere through atmosphere, more will be the loss of insolation. More will be the loss of insolation. More will be the loss of insolation. By the time a slanting sun's rays, by the time a slanting sun's rays reaches the surface of Earth, reaches the surface of Earth, comma, it will be a faint rays. It will be a faint rays. Within bracket, you can write it as devoid of energy. Right, within bracket, you can write it as what? Devoid of energy. Right, my friends. So, what is this angle of sun's rays, distance traveled by sun's rays through atmosphere? Both we have taken it. Okay. Now, the third factor, my friend. Third factor is very simple. Very simple. It's not so technical, right? And now about the third factor. Okay. And one more thing. I have given you two factors, right? I'll give you the consolidation of this factor, right? Very good. See, I've just given you. Only thing is that I have made the surface of the Earth to be flat, but in reality, how exactly this looks like? See, take a very close look, my friend. Both if I'm just taking as a consolidation, right? Two factors I have given you, right? It means one, the factor number one, what I've just discussed is what? The angle of sun's rays, my friend. Somewhere you can find it, right? At what angle the sun's rays is falling? See, vertical sun's rays, right? It is making the maximum angle, my friend, 90 degree, correct? It is making it that 90 degree. Somewhere here I can find that it is making some angle, am I right? Which is not 90 degree, which is less than 90 degree, correct? This is what I call them as what? Angle of sun's rays, my friend. And number two, I see, that's what I told you, right? Angle of sun's rays, higher is the sun's position, right? It will be concentrated in a smaller area, right? See, and about the slanting sun's rays, it gets concentrated in a larger area, distributed in a larger area. This is number one. Number two, the distance traveled by sun's rays through atmosphere. See, high sun position travel a small distance, whereas slanting sun's rays travel a long distance. That's what I said, right? Longer is the distance traveled by sun's rays through atmosphere, more will be the loss of energy. Am I right? More will be the loss of energy. Okay, right, my friend. So both the factors we have taken it, correct? Now coming to the third factor, my friend. Coming to the third factor, it is seasons, or you call them as what? Length of day. Seasons, or simply you say length of day, my friend. You call them as what? Length of day. Only thing is that I should make it so simple as possible. Let's see. Now comes the question. What do you mean by season, my friend? When I talk about summer, when I talk about winter, what do you mean by seasons? Any idea? What do you mean by season? Summer. If at all, if I am just bringing the character of summer, what exactly you mean by season, my friend? What do you mean by summer? Any idea? Change of weather. Accepted. Make it very simple. What is the major difference between summer and winter? What is the major difference between summer and winter? Temperature. No. Temperature I understand, but temperature is not the major difference, my friend. Earth phases. Okay, I am giving you, my friend. If I'm just asking you, what is the defining character of summer? Right, only one you have to choose. When talk about summer, summer is known for warmer days or longer days, my friend. I understand both, but I'm just asking you to pick one. Which is more defining character of a summer? Both. Summer is warmer, summer is longer, right? Summer is known for early sunrise, and summer is known for what? Late sunset, everything I understand. Summer is known for longer days, shorter nights, very warm condition, everything I have, right? Very good. What is preferred is longer days. So my dear friends, even equatorial region throughout the year, what you experience is what? Warm condition, but equatorial region do not experience season cycle. The only region in the world which do not experience season cycle is equatorial region. But throughout the year, equatorial region experience warm condition. Correct? And my dear friends, as I said, very good, well said. The most defining character of summer is what? Longer days, my friend. Okay, longer days. Winter is shorter days. Any day when the sun rises before 6 a.m., am I right? That is summer. Correct? Any day when the sun rises after 6 p.m., it is winter. I'm talking about local time, my friend. See, in northeastern states, the time which is followed is erroneous. Am I right? So do not calculate. When I say before summer, every day, even in your winters, sun will rise before 6 a.m., my friend. Right? Because I understand the time itself which is followed in northeastern state is wrong. Right? It's wrong. Right? India should have 2 time zones, but unfortunately, India is following only 1 time zone. Right? Northeastern state and Gujarat is the victim of both. Okay. My dear friend, the sun, normal days, my friend, sun will rise 5 o'clock early in the morning, northeastern state. Gujarat, the sun will come only at 7 o'clock, 7 a.m. Am I right? Okay. So somewhere, whatever it is the case, I have to go by local time. So whatever it is the case, summer means longer days, winter means shorter days. That's the reason. Simply I said, season means what? A length of day, my friend. Nothing else. Okay? Right. Now, what exactly is an idea? When I talk about summer, right? We know when I talk about summer, length of day will be more, my friend, right? So length of day will be more, longer days. So if the days are longer, right? The days are longer, my friend, longer days. I understand. More will be the amount of insolation absorbed, right? Somewhere I'll just use symbols. More will be insolation. Correct? Concentration of insolation will be more. On the other hand, when I talk about winter, winter is known for what? Shorter days, my friend. Right? Shorter days. So if you're there, shorter days, talking about shorter days, insolation amount will be less. Right? Insolation will be less. Right? The amount of insolation will be less, my friend. So that's the reason normally winter will be cold. Okay. And my dear friends, all 3 factors you have to take it together. Right? Only one factor will not help you out. For example, if you're considering the 3rd factor in isolation, completely you will go against the knowledge what you have. Because somewhere I'm just saying summer means longer days. Correct? Summer means longer days. If longer is the day, more will be the insolation. See, for example, if I'm there in the poles, my friend, the length of day at North Pole and South Pole is 6 months. So it gives you an idea that it should be very, very high in its temperature. Am I right? But it is not the case. That's the reason always I'm telling you, right? Predominantly, it is angle of sun's rays. Along with the angle of sun's rays, you should also take it into consideration of other factors. How should I understand this? I'll tell you slightly better. All the factors put together, how can I make a relation? I'll give you one example, my friend. Okay. I am giving you two different regions on two different dates. Okay. Right. Equator on March 21st versus equator on March 21st versus Tropic of Cancer on June 21st. You have to tell me which day will be warmer. Equator on March 21st versus Tropic of Cancer on June 21st. You have to simply tell me which day will be warmer, my friend. Which day will experience more temperature? Which day will experience a hot, okay, very high temperature, my friend? Tropic of Cancer on June 21st or equator on March 21st. My dear friends, both these places on the said day, my friend, angle of sun's rays is going to be 90 degree. There is no denial. On March 21st, sun's vertical rays is going to fall on equator. June 21st, right, the sun's vertical rays is going to fall on Tropic of Cancer. Right, angle of sun's rays is same. Then what is making the difference? What is making the difference, my friend? What is making the difference is the length of the day. Any given day at equator will be 12 hours, my friend. But when I talk about Tropic of Cancer on this day, the length of the day will be 13.5 hours. 13 and a half hours, my friend. So I understand, right? June 21st will experience a warm condition than that of what? March 21st on equator. Okay. See, I am going for date specific. I am simply not comparing tropical and equatorial region. That is not my comparison. Right? I am comparing between two places of a specific days. Okay. Right, my friends. Okay. This is all about insolation. So with all aspect, my friend, with every aspect, right, I have just covered insolation. Okay. Right. Now insolation is done. Right. Okay. So we have completed insolation. Now we have to take the case of what? Temperature. Right. Atmospheric temperature. All right. Okay. So first, we'll define atmospheric temperature. Then we'll say how exactly this atmospheric temperature varies from place to place and time to time, right? So let me tell you, the second topic what we are venturing towards is what? Atmospheric temperature. Atmospheric temperature and insolation, they are very closely related, my friend. Very closely related, because I understand wherever insolation is higher, right, atmospheric temperature is also high. So you can write it. What is atmospheric temperature? The amount of heat present in the lower reaches of atmosphere. Amount of heat present in the lower reaches of atmosphere is called as atmospheric temperature. It's called as atmospheric temperature. Right. Further, you can write though insolation determines atmospheric temperature. You can write it. Though insolation determines atmospheric temperature, comma, the direct source of atmospheric temperature. You can write it. The direct or immediate source of atmospheric temperature. Direct or immediate. Right? You can write it. Direct or immediate source of atmospheric temperature. Immediate source of atmospheric temperature is terrestrial radiation. Right? The direct or immediate source of atmospheric temperature is terrestrial radiation. Yesterday's class we have seen, right? Insolation will heat up the surface of the earth, and in turn, the heat that is liberated from the surface of the earth is the one which will heating up what? Atmosphere. So the direct or immediate source of atmospheric temperature is what? Terrestrial radiation. Right, my friends. So what is atmospheric temperature we have seen. Now only thing is that we have to talk about why insolation, or what are the factors which is affecting this distribution of temperature from place to place. Then we'll also discuss about one very important concept called as heat budget. Right? What is a heat budget? Right? Why? Right? Say for example, what is the difference? Say for example, what are the different ways how this insolation gets affected, and what are the different aspects of atmosphere or factors in atmosphere which either reduces or increases the temperature. Right? Right. So some of the factors we'll be discussing. Right? So we'll take a break. We'll come back at 4:15, my friend. Okay. So let the link be live, right? We'll come back at 4:50. So right, my friends. Okay. Now, so we'll just continue from where we have left. Okay. So we just started with the atmospheric temperature. So somewhere I said the amount of heat present in the lower reaches of atmosphere is called as atmospheric temperature. And I've also told you that the direct or immediate source of this atmospheric temperature is what? Terrestrial radiation. Sun's rays is only an indirect source, my friend, right? It's an indirect source. Okay, right. Now, only thing is that we have to talk about how this temperature is varying from place to place, because we know that insolation itself varies from place to place. So I should also talk about the variation in the temperature. So before talking about the distribution in the temperature, first and foremost, right, let me talk about one small concept called as heat budget, my friend. Heat budget. So what is this heat budget, if you ask me? The name itself says it is budget. Okay. So somewhere you can write a very small definition. What is this heat budget? The balance between incoming solar radiation, the balance between incoming solar radiation and outgoing terrestrial radiation is called as heat budget. So it is the balance between incoming solar radiation and outgoing terrestrial radiation is called as heat budget. Okay. Right, my friends. Okay. Okay. Just excuse me for a minute. So a minor disturbance, right? So somewhere I told you that the heat budget is the balance between what is incoming and what is outgoing, my friends. See, that's what you call them as a budget, right? Whenever you experience a balance between what is incoming and what is outgoing, you call them as what? Budget. Now comes the question, what is incoming, my friend? When it comes to heat, sorry again. Right, my friend. So I was just talking about the balance that happens between incoming solar radiation and outgoing terrestrial radiation, right? So my dear friends, so we know the fact that what exactly is incoming, right, is what the insolation, my friend. right? You call them as what in insulation. See, insulation, you call it by different names, right? Say, for example, I call them as insulation. Okay. Sometimes I also call them as what? Ultraviolet or short wave radiation, my friend. You call them as what? Ultraviolet, right? Or we call them as what? Short wave radiation. Short wave or ultraviolet radiation. These are the different names, right? What exactly this insulation takes, my friend. See, it gives you a logic, right? Wavelength is ultraviolet. Ultraviolet itself has a very short wavelength. That's the reason you call them as what? Short wave radiation. Sometimes you call them as what? UV radiation. As simple as this. Now, my dear friends, what exactly happens? Somewhere you know, for all practical purpose, that insolation amount what Earth as a system receives, for all practical purpose, we have taken it as what? 100 percentage, my friend. Okay. Now comes the question, is this 100 percentage ultimately reaches the surface of the Earth? Answer is no. Because already we have seen, my friend, right? Say for example, ozone as a layer itself has reduced this insulation, correct? So somewhere we know what percentage of insulation is reduced by ozone, right? So somewhere we know the fact that, for example, all this absorption, right? I am representing using this, right, symbol called as plus. Plus is absorption, my friend. 14 percentage of insulation is absorbed by what? Ozone, my friend. Right? It is absorbed by ozone. Correct? Now, what is remaining is 86 percentage. What comes to troposphere is only 86 percentage. And my dear friends, in this 86 percentage, what happens, my friend? Right, say for example, 86 percentage, 6 percentage of this insulation is almost lost by aerosols, my friend. Minus 6, I'll put it as minus 6. Minus 6 percentage is lost by aerosols. Right. Aerosols will reduce insulation. You know what is aerosol, right? Even yesterday's class, I was just talking about aerosols. What is an aerosol? Suspended solid particles in atmosphere. Dust is the finest example of this aerosol. Okay. So aerosol reduces insulation. If you ask me what is the process by which aerosol reduces insulation, my friend, it results in what? Scattering. Aerosol scatters insulation. Okay. So in 86, my friend, right? 6 is gone. Now comes the question, what is remaining? Remaining is what? Say for example, 80 percentage. And my dear friend, 27 percentage is reduced by cloud. Cloud. If you ask me, say for example, if you have a cloud, my friend, right? Cloud reduces insulation by 27 percentage. What is the process by which cloud reduces insulation, if you ask me? It is by the process of what? Reflection. Right? Reflection reduces insulation by 27 percentage. Okay. So out of 80 percentage, 27 percentage is gone. What is remaining? 53. Okay. So this 53 percentage finally reaches the surface of the Earth. And even in this 53 percentage, my friend, right, further 2 percentage is reduced by ice caps, my friend, by ice caps. And if you ask me what exactly is the process by which ice cap reduces insulation, again reflection. It is again reflection, my friend. See, calculate. In 86, 6 is gone. Just a minute. So somewhere I said in 86, 6 is gone, my friend. 6 is gone by what? Aerosols. Right? What you have is remaining only 80. In 80, another 27 is reduced by cloud cover. Correct? Right. and what is remaining is only 53. And in this 53, my friend, in this 53, right, understanding says, right, 2% is reduced by ice caps, my friend, 2%, right, and 2 is gone. And finally, what percentage of insolation finally reaches the surface of the earth? What is absorbed by the surface of the earth is only 51 percentage, my friend. Is only 51 percentage. What you very popularly call as what? Simple majority, correct? What Assam was looking for, what Tamil Nadu was looking for elections, am I right? My dear friends, what is absorbed by the surface of the earth is only half the insulation that comes to the earth as a system. Am I right? So somewhere, my dear friends, here logically we have seen what are the different constituents in atmosphere which reduces insulation. Aerosols reduces insulation. Ozone reduces insulation, but only problem is that difference. I should not say problem, only difference. Ozone reduces insulation by absorbing insulation. It filters insulation. Aerosol scatters insulation. Cloud reflects insulation. Ice caps reflect insulation. Right? After all the losses, 49% of insulation is lost, my friend. Right? What finally reaches the surface of the earth is only about 51%. And my dear friends, right, when I talk about, say for example, all these factors, only the major factors I have just given. Okay, all minor factors I have not given. Now, slightly let me deviate, my friend. See, when I talk about cloud and ice caps, right, if you ask me what means cloud and ice caps, my friend, clouds and ice caps, right, they reflect insulation, my friend, right? Both of them, they reflect insulation, right? They reflects insulation. And whenever it reflects insulation, this process of reflection of insulation is very popularly called as albedo, my friend. It's very popularly called as albedo. Okay. So albedo is nothing but what? Reflection of insulation. Okay. Right. And somewhere, if you're asking me, see, make it very simple. Albedo is nothing but what? Reflection of insulation. Whatever is the complex language that NCERT talks about, forget about it. You make it very simple. Albedo is nothing but what? Reflection of insulation. Cloud reflects insulation. Ice cap reflects insulation. Right, my friends? And if you ask me, which is that atmospheric component which has maximum albedo factor without any denial, it is what? Cloud. If you are there on the surface without any denial, it is ice caps, my friend. Right. And my dear friends, let me also bring you one relation. What is the relation? See, global warming, global warming, and melt of glacier, my friend. Right? There is one relation, right? Melt of glaciers. What is the relation, if you ask me? You know what is global warming, right? If the temperature of the earth increases, you call them as what? Global warming. Average temperature if it increases, right? Now, what happens when the average temperature of the earth increases? I understand more will be the melt of glacier, my friend. On the other hand, when you have more melt of glacier, what we call them as what? Deglaciation. We call them as what? Deglaciation, my friend, right? This deglaciation will again increase the global temperature. If you ask me how, the reason is very simple. When glaciers are removed, right, this 2% of insulation is affected, my friend, right? This 2% of insulation is affected. See, tomorrow, if all the glaciers are removed from the earth, correct, earth will not absorb 51% of insulation. Instead, earth will absorb what? 53% of insulation. That's the reason we say it is more like a vicious cycle. If temperature increases on one side, right, I understand, right, glacier will melt on the other side. On the other hand, if glaciers melt, right, temperature again increases because it affects this albedo factor. Okay, a very important correlation. And my dear friends, see, everywhere you find this albedo factor or you find this albedo element, my friend. Everywhere you find it. Okay. Now, why I'm saying so, I'll tell you. Even every ground object has this albedo element. See, for example, if two cars are parked in the hot sun, one car is white and one car is black, my friend. Right? Somewhere I understand this dark colored car will be hot. If you touch it, it will be very hot. White, it will be very less. Why? Because it has different albedo element or albedo factor. Okay. See, say for example, if you're going to some pilgrimage center, my friend, somewhere if you're about to walk in the hot sun without, say for example, your right sandals or footwear, right? Normally you'll be finding that you'll be having this white stripes, my friend, white stripes. Why exactly white stripes you'll be finding in, say for example, pilgrimage center in the sense, it increases that albedo factor. White and smoothness of the surface. White and yellow has the maximum albedo element. That's the reason. Even nowadays, you'll be finding the terrace of the buildings. Now they are shaded white in color. Why? Right. They will reflect more insolation. If they reflect more insolation, the net absorption of heat will be very less. Okay. Practical utility of albedo. Okay. Right. So somewhere in heat budget, we have talked about the different factors which reduces this insolation. Right. Somewhere we talked about. Right, my friends. Now, what is this heat budget? Heat budget is a balance that exists between what? Incoming solar radiation and outgoing terrestrial radiation. Okay. Now I have to talk about that terrestrial radiation. Whatever, right? Whatever is absorbed by the surface of the earth has to be liberated back. Okay. Now all this 51 percentage has to be liberated back, my friend. Okay. Now out of this 51 percentage, what is liberated back, my friend, right? 71 percentage of this terrestrial radiation directly escapes to exoatmosphere, my friend. It escapes directly, 17 percentage. And you call it by different names, right? You call them as terrestrial radiation. Take the clue from the previous name, my friend. Otherwise, you can call them as what? Long wave, right? Or you call them as what? Infrared radiation. All these names or the other names of what? Right. Terrestrial radiation. Okay, right. Now, my dear friends, out of this 51, 17 is gone. What is remaining, if you ask me? Remaining is what? 34. This 34 percentage of insolation is temporarily absorbed by, right? 34 percentage of insolation is absorbed by gases like carbon dioxide, my friend. Okay. See, all this plus symbols, what I am using is for absorption. That's the reason I said, my friend, in insolation, only 14 percentage of insolation is absorbed in the atmosphere. But terrestrial radiation, 34 percentage is absorbed. And that too, this absorption takes place in troposphere. Correct. And about 14 percentage, this absorption takes place in what? Stratosphere, my friend. Okay. So that's the reason I said the major contributor of this heat. Am I right? The major source of this heat is what? Terrestrial radiation, my friend. Right? Not the insolation. Okay, whatever be the case, right? Somewhere I have just brought the balance between incoming solar radiation and outgoing terrestrial radiation. Right. Now, when I talk about carbon dioxide, somewhere it is worth discussing about carbon dioxide, right? If you ask me what is the percentage of carbon dioxide, it is 0.036 percentage. Rounded off figure, yesterday we have taken it to what? Taken it as what? 0.04 percentage. The 0.036 percentage, my friend, of carbon dioxide holds back what percentage of insolation, if you ask me? It is 34 percentage of insolation. It means what? Approximately it is 1/3 of insolation and it is 2/3 of terrestrial radiation, my friend. Right? That's the reason normally we say tomorrow, if the 0.04 is becoming 0.05, my friend, say for example, assume theoretically, assuming it is becoming 0.05, idea is Whatever heat that comes in will not go back, my friend. That's the reason normally we say carbon dioxide is very sensitive, my friend. Carbon dioxide has to be maintained in the permissible limit. Permissible limit. See, and you may wonder, right? See, today carbon dioxide is only 0.036 percentage. But if I just talk about early atmosphere, primitive atmosphere, when atmosphere had its formation, 97 percentage was carbon dioxide and only 3 percentage was nitrogen, my friend. Things have changed. I am talking about the current situation. I'm talking about the current situation and say, for example, the biospheric reserves and the larger biome, what survived today, it depends on the very sensitive temperature oscillations. Am I right? Right, my friends. So somewhere I understand, right? I understand the potential of carbon dioxide in being a greenhouse gas. Now, just 0.036 percentage, but holding back 34 percentage of insulation. Nearly 1/3 of the insulation it holds back, my friends. Okay, right. So what is heat budget? We have an idea. Now, my dear friends, now comes the question. What about carbon dioxide? Do we need carbon dioxide? Is this carbon dioxide so important? Okay. And my dear friends, let me tell you, greenhouse gas. What is the importance of greenhouse gas, my friend? Are they important? That's the question. Are they important? Assume a condition that carbon dioxide is not there, my friend. Just assume. Assume if carbon dioxide is not there, what can happen, my friend? Somewhere if carbon dioxide is not there, what can happen? See, carbon dioxide is very essential. Now, only thing is that I am asking you a question. Okay, just give me an answer, right? Right. Imagine a situation that world has no carbon dioxide. No carbon dioxide. What all can happen, my friend? Number one, this question itself will not arise because we will not exist to discuss about this question. That is obvious. Okay. Otherwise, purely putting on the side of climatology, my friend. If carbon dioxide would have not been there, very good. No plants accepted, very good. Right. If I'm just talking about temperature, my friend, if carbon dioxide would have been not there, the temperature of Earth would have been extremely cold. See, when I talk about greenhouse gas, right? Greenhouse gas, yes. Temperature would be too cold to live, yes. Greenhouse gas, my friend. Greenhouse gases are very essential gases. Okay. Only thing is that, see, nowadays this greenhouse gas, carbon dioxide is demonified. Am I right? It almost given the picture of a demon. But actually, let me tell you, my friend, it is more like an angel. Am I right? See, I would always say that the greenhouse gas is more like a necessary evil, my friend. Something like marriage. Okay. So when I talk about greenhouse gas, right? Particularly when I talk about carbon dioxide, my friend, it is very, very important. Very, very important. Now, if you ask me, okay, going by facts, let me go by facts, not by assumptions, right? If carbon dioxide would have not been there, one statistic says that Earth would have been colder by, the same Earth, my friend, would have been colder by 33 degrees centigrade, my friend. Today, if you ask me what is the average temperature of Earth, it is approximately 15 degrees centigrade. To be very precise, 15.2 degrees centigrade, my friend. If no carbon dioxide, my dear friends, this Earth would have been minus 18 degrees centigrade average temperature. Right? It means what? Outside, say for example, somewhere outside Guwahati, if you're just seeing, so you'll be finding glaciers everywhere. All right. So Earth would have been extremely cold. That's an idea. Okay. Number two, my friend. If carbon dioxide would have not been there, the night temperature of the Earth would have been extremely cold. We call them as a diurnal temperature, my friend. We call them as a diurnal temperature. What is this diurnal temperature? The variation of temperature between day and night, right? Day maximum minus night minimum, or the range of temperature in a single day, we call them as what? Diurnal temperature. This diurnal temperature would have been extremely high, right? I repeat, my friend, factually, forget about the life on Earth, forget about the plants. Purely, if I'm just talking in case of temperature, right? One idea says if carbon dioxide would have not been there, Earth would have been colder by 33 degrees centigrade. Number one. Number two, right. Diurnal temperature difference would have been extremely high. Or I should say, as somebody said, right, night will be extremely cold, my friend. Okay, night will be extremely cold. Almost everybody, right? Right, almost. What you said is perfect. Okay, Chaudhary, Pankaj, Sneha, Robin. Okay, almost what you said is perfectly right. Okay, right, my friend. So carbon dioxide is very important gas, my friend. Only thing is that it has to be maintained within the permissible limit. Okay, right. Now, what is the heat budget? Approximately, we have an idea. Now, my dear friends, after discussing about heat budget, what I'll do, right? Right. So somewhere we'll discuss about the distribution of temperature. Okay. Horizontal, let me call it as what? Horizontal distribution of temperature. So let me talk about this horizontal distribution of atmospheric temperature. See, whenever I talk about the horizontal distribution of atmospheric temperature here, I'm going to talk only about what? Tropospheric condition, tropospheric temperature. That to the lower reaches of troposphere I'm going to discuss about. Okay. Now, my dear friends, somewhere, we said that insolation differs from place to place. If insolation distribution itself is different, temperature difference is also obvious. Okay. So somewhere you can write a very small paragraph, right? You can write it. Right, you can write it. Since insolation distribution varies from place to place and time to time. Since insolation distribution varies from place to place and time to time. The distribution of atmospheric temperature also varies from place to place. And time to time. The various factors which influence the distribution of atmospheric temperature are you yourself can tell me, my friend. We'll go for a brainstorming session, right? You have to tell me, see, things are very simple, right? Make it very simple. What are the different factors according to you makes the difference in horizontal distribution of temperature? It means what? Simple. Why few places are warmer, why few places are colder? That's the question. Right? What can be the potential reason, my friend? Only the surface, you don't go for vertical, right? Say, for example, the vertical distribution of temperature, only horizontal distribution of temperature. Give me some of the facts, my friend. You know it. Okay. Pressure. See, pressure, it's a result of temperature, my friend. Okay. Topography, altitude, but more than altitude, my friend. If I'm just going by logic, right? Order of importance, not logic, I should say, order of importance. It is latitude, correct? Latitude, my friend, right? Latitude. That's the reason lower latitude experience. See, for example, just now we have seen, right? Lower latitude experience what? High sun position. Higher latitude experience what? Slanting sun's rays, my friend. Latitude plays a very important role. Of course, I understand. Apart from latitude, yes, what you said is what? Altitude. Correct. Some of you have given me the name of altitude. Very good. Fantastic. Right. Right. Topography. You said topography, no problem. Right. Latitude and altitude plays a very important role. And altitude. That's the reason. Mountainous regions are colder. Why Shillong is colder? Guwahati is warmer. Reason. Altitudinal difference. Am I right? And my dear friends, right, say for example, very good. Another point also I got it, right? You call them as what? Continentality. Okay. Right. One of you have said as what? Continentality. Right. Either you call them as what? Continentality, or as you say, you can also call them as what? Distance from sea, my friend. See, just now we talked about the case of Australia, right? I told that Australia cities are located in what? The coastal areas. Right? Why? Because water has the ability to maintain temperature. Okay. See, the case of India itself, I'll take it. I'm just taking four cities, my friend. Okay. Delhi, Mumbai, Chennai, Kolkata. I'm just taking four cities. Right. Now comes the question, right? Out of these four cities, my friend, which is an odd man out, everybody knows, my friend. Among the four cities, what I have just given, which is the odd man out? Odd man out is what? Delhi. Why it is odd man out? Because I understand all three other locations, they are coastal areas. Kolkata is not exactly in the coastline, I agree, right? But I understand there is also what? The coastal region, my friend, very near to the coast. Delhi located in inland region. Now you have to answer a simple and straightforward question. I have just given you four cities, am I right? Now you have to tell me, during the month of summers, say for example, you are there in the month of May, my friend, somewhere, May, early June, correct? Among the four cities, what I have taken as an example, Chennai, Mumbai, Kolkata, and Delhi, which city will experience the highest temperature, my friend? Simple. Which city will experience the highest temperature? Delhi, very good, Delhi. Right, fine. Among the four cities, the highest temperature will be recorded in what? Delhi. Fantastic, good. Now I have one more question. You are in the month of December. You are in the month of January. Among the same four cities, Mumbai, Chennai, Kolkata, and Delhi, you tell me, my friend, which city will experience the minimum most temperature? The minimum temperature, my friend. Again, it is Delhi, right? See the beauty. The warmest, I would say, the hottest or the highest temperature is also recorded in Delhi. The lowest temperature is also recorded in Delhi. Be the diurnal temperature or annual range of temperature, right? As you move away from the coastline, coastal area, right, the variation in the temperature is going to be very high. But that is seasonal, right? This difference is going to be seasonal. This concept is what we call it as what? Continentality or distance from sea, my friend. Okay. And my dear friends, right? If you're there in a coastal region, say for example, assume, I'll show you one image. I do not know how far you can understand this image. To some extent, my friend, to some extent, I'll also tell you, means somewhere I'll just give you a broad idea about this image. So when I talk about, say for example, try to imagine this means somewhere, right, somewhere, try to relate this image, my friend. See, I'm just taking the case of Africa. See here, blue is given, blue is taken as the color of representing a cold condition. And say for example, orange, red is taken as the means almost representing the color of hot condition. My friend. See somewhere, I'm just taking the case of, right, Africa, my friend. Very carefully, if I look at Africa, put yourself only in the coastal regions, right? You're there in the coastal regions, my friend. Okay, you're there in the coastal regions, right? You're there in the coastal regions. Okay, you're somewhere. What I'm just doing, two coast I'm just comparing, my friend. Two coast I'm comparing. Okay. Latitudinally same latitude, altitudinally same, but when I talk about temperature, right, eastern coast of this continent has a warm condition and western coast of a continent comparatively it has a cold condition. See here it is red color, slightly here the same latitude on the western side what you have is a dull color. Am I right? Right. Similarly, you take the case of South America, my friend. Same latitude. Okay. East coast, what you have is warm condition, and west coast, what you have is a cold condition, my friend. Every continent you take it, same latitude, you have, right, warm waters along the eastern coast, right, or I would say warm conditions along the eastern coast and cold condition along the western coast. All right. Now, somewhere, my friend, can you at least give me an intellectual guess? What can be the potential reason for it? Any continent you take it, eastern coast of this continent will be warmer, and western coast of the continent along the same latitude will be colder. Right? Can you at least give me an intellectual guess, my friend? What can be the reason for it? Just give it an intellectual guess. Just give it a guess. What can be the potential reason for it, my friend? Airflow direction. And one more thing, I have just given you a clue, right? What is the clue? Coastal regions. That's a clue. You're there in the same latitude, but the comparison is between eastern coast and western coast. Very good. My dear friend, I'll just superimpose it. See, you have a concept called as ocean currents, my friend. You have a concept called as ocean currents. Ocean currents plays a very important role, my friend. Okay. Now see here, somewhere, only two types of ocean currents you have. Okay. Either you call them as what a warm current, or you call them as what a cold current, my friend. See, somewhere. What is given in red in color is what warm currents, and what is given in right blue in color is what cold current, my friend. So whenever I talk about the western side of the continent, any western side of the continent you'll be finding that comes under the influence of a cold current. Any eastern side of the continent comes under the influence of what? Warm current. See, everywhere you take it. Western coast of means western coast of America, cold current, eastern coast warm current, right? Africa, west coast cold current, east coast warm current. Australia, west is cold, east is warm. Am I right? Similarly, when I talk about Asia, eastern coast is what? Warm. Am I right? My dear friends, that's the reason I said water currents or ocean currents also plays a very important role. Am I right? Very important role. Okay. So number 3, my friend, sorry, to be very precise, number 4. When talk about factor number 4, it is ocean currents. Ocean currents plays a very important role. My dear friends, wind also plays a very important role. But wind I'll just explain at the later stage. Okay. So these are some of the factors which influence the temperature of a particular place, my friend. Okay. Not only these ocean currents and winds, I tell you, even I have plenty of local factors, my friend. Plenty of local factors. Okay. When talk about local factors, what are the local factors if you ask me, right? Local factors like clouds, right? Local factors like aerosols, right? It means all these, okay, I'll put it this way, clouds, water vapor, right? Factors like aerosols, right, etc. My friend. So these factors, we call them as what? Local factors, which will change from place to place. Sometimes all of a sudden, right, all of a sudden I'll be having a cloudy days, am I right? More is the cloud, insolation will be reflected. If water vapor, humidity is more, certainly speaking, it is going to affect the temperature, am I right? So when I talk about aerosol, supply is high in the atmosphere, it is going to affect the temperature. So these are some of the factors which is, say for example, which is going to affect the temperature of a particular place, horizontal distribution of this temperature. Correct? So only thing is that we have to discuss one by one, my friend, one by one. Okay. So how latitude is going to affect, how altitude is going to affect, what is this continentality, how this ocean current is going to affect. All right. So one by one in detail we'll discuss. Okay. Right. I'll take it. I'll just give you a detailed information. Okay. First, I'll take the case of latitude, my friend. See, we know the fact, right? When talk about latitude, simple, right? You increase the sign of latitude, what is going to happen? Temperature is going to decrease, my friend. Right? Everybody knows. Why? Because insolation is going to decrease. Correct? It is all because with increasing latitude, insolation is going to decrease. As simple as this. Right? With increasing sign of latitude, the temperature decreases, insolation is going to decrease. Correct? Now, my friend. Okay. So, right. So, one is latitude. Now, everything is fine. My dear friends, only based on latitude, Greek scholars have classified the entire Earth, right, into different climatic divisions, my friend. Only based on latitude they have done it, right? Very popularly, they were calling it as what? Thermal zones. They were calling it as what? Thermal zones. Now, what is this thermal zone? See, our reference of the same, slightly we'll take it in a different way. But when I talk about Greek scholars, my friend, right? What exactly? According to them, they have classified and divided the entire Earth into 5 regions, my friend. 5 thermal zones. What are they? Approximately what you find is what? So they have just almost, they have divided the entire Earth into 5 thermal zones, my friend. I'll just rewrite it. I'll redraw it. We call them as what? Thermal zone. Now, Greeks have divided entire Earth into different thermal province, my friend. So accordingly, what they have done, all that region that exists between Tropic of Cancer and Capricorn, my friend, right? All that region that exists between Tropic of Cancer and Capricorn, right? Separated by equator. They were calling it as what? Torrid zone, my friend. They were calling it as what? Torrid zone. See, according to them, right, torrid means very warm region, my friend. Right, torrid means literally torrid means what? Warm regions. Am I right? They are warm regions. According to them, they strongly believe that human cannot live in this region, but they do not know that Indians is capable of living in this region. Okay. Torrid means very warm region, my friend. Right. So where exactly you have the extension of torrid? Between this Tropic of Cancer, between Tropic of Cancer and the Tropic of Capricorn, my friend. Right. So this is a place where you have the right occurrence of what? Torrid region. See, we may slightly use a different parlance, right? Greek scholars' parlance is different. What is our parlance, if you ask me? We may slightly use it. What I'll just give you our parlance also, right? Normally, my friend, right? See, this is what our parlance, the popular parlance, my friend. The same thing, we call them as what? Tropical zone. Tropic to tropic, right? We call them as what? Tropical zone, my friend. Tropics to tropic, we call them as what? Tropical zone, right? But the Greeks were calling it as what? Temperate, means torrid region, my friend. And say, for example, between this okay, Tropic of Cancer to Arctic Circle, right? Tropic of Cancer to Arctic Circle, and Tropic of Capricorn to Antarctic Circle, my friend. Okay. Greeks were calling this region as what? Temperate region, my friend. They are calling it as what? Temperate region. According to them, temperate means moderate, my friend. They were calling it as what? Temperate. So according to them, temperate means moderate. That is the meaning of this temperate. And beyond it, right, what you have is completely a frozen region, my friend, right? They call them as what? Frigid zone, my friend. They were calling it as what? Frigid zone. Okay. Completely extremely cold, they were calling it as what? Frigid zone. Right, extremely cold, my friend. Extremely cold, frozen region. Right? Frozen, right? Or extremely cold. Right, this is what they were calling it as what? Frigid zone, my friend. Okay. Now, what exactly, how these Greek scholars have divided the entire earth into different regions, approximately we have an idea. See, this classification is made completely based on what? Latitude alone, right? No other factors are taken into consideration. Okay, no height, no continentality, right? No influence of water, nothing, my friend. Okay, right, right. So exactly we describe that also I have just given you, right? Our parlance, my friend, our day-to-day parlance. Right. Normally, when I talk about Tropic of Cancer to Capricorn, we call them as what? Tropical region. Right. Then Greek parlance, our parlance, both are same, and beyond it, what you call them as what? Polar region. Okay. Right. So what is this Greek's classification? Thermal zones. Right. By Greek scholars. That also I'll write it by Greek scholars. Right. Right, my friends. Okay. So somewhere I have justified the factor called as latitude. Okay. Now, coming to the second factor, my friend. What is the second factor? Altitude. Okay. Altitude is the second factor. So when I talk about altitude, simple, right? What is altitude? Altitude means height, my friend. Okay. Altitude means height. Now everybody knows, right? You increase the height or altitude. You increase the height or altitude. Right. What exactly happens? Right. the temperature decreases, my friend. Temperature decreases. If you ask me what is the reason for it, reason is very simple. It is all because of what? Normal lapse rate, my friend. If you are there in troposphere, every 1 kilometer of increased height, you increase the height by 1 kilometer, you know the fact. Temperature decreases by what? 6.5 degrees centigrade. Right? Very normal lapse rate. You call them as what? Normal lapse rate. Right? Temperature decreases by 6.5 degrees centigrade, my friend. Why? Everything we know, my friend. Why? Because I understand the direct source of atmospheric temperature is what? Terrestrial radiation. Okay? That is the reason. Okay. So altitude we have taken it. Right. And very important, somewhere I said it is normal lapse rate. See, I have just given you 5 factors which influence the temperature of a particular place. Never take only one factor, my friend. Always it's the combination of this factor. Why? I'll tell you. See, you have you heard anything about or any word like this, my friend? Right, there is a mountain called as Verkhoyansk. Right, have you ever heard about this name, my friend? Verkhoyansk. Right. Any idea, my friend? What is this mountain? Where exactly this mountain is located? Any idea? Right, it means you had an idea. Yes. Okay, yes is okay. Russia, very good. Verkhoyansk. My dear friends, this mountain is there in Russia. Siberia, Russia, my friend. Right, it is located in what? Siberia, Russia. Siberia, Russia. And my dear friends, this mountain has a nickname, my friend. You ask me what exactly is the nickname that this mountain has. This mountain has a nickname. This mountain is very popularly called as what? Cold pole of the world. Okay. Himalayas is called as a third pole of the world, but this mountain is called as what? Cold pole of the world, my friend. Of the world. Okay. Now, if somebody is saying that one mountain is called as cold pole of the world, my friend. Okay. That is the case, can I say, somewhere I understand this mountain can be the coldest place on earth. See, this is highly debatable. Right? Few of the sources says this is the coldest inhabited place. Few of the sources says, okay, forget about the inhabited place. If I just talk about the peaks of the mountain, the elevated region of the mountain, this mountain is one of the coldest places on earth. My friends, my question is very simple. Can a mountain which is not located at the poles, right, which is neither located at the poles, nor this mountain is the highest or the tallest mountain in the world, but still, can it be the coldest place on earth? Possible. This mountain is neither located on the poles, nor this mountain has the tallest or maximum height, my friend. In spite of the fact, right, few facts says that this mountain is the called as cold pole of the world. Idea says this mountain can, right, almost this mountain can is considered as the one of the coldest place on earth, my friend. Is it possible? If you ask me, I would say a big yes, my friend. Big yes, right? So very much possible this mountain can be a coldest place. Why? I'll tell you. See, altitude or latitude should not be seen in isolation, my friend. Always it should be seen in a combination. That's the reason I said always I should take it as the product of latitude and altitude. My dear friend, Verkhoyansk as a mountain is already located in higher latitudes. Latitudinal value is also high. Almost it is there in polar region. Altitude of the mountain is also significantly higher, my friend. You take the product. A mountain which is already located in a polar region, right, the outer periphery of this Arctic Circle. And the height of the mountain is also considerable. So by all means, this mountain you can experience what? The highest temperature, my friend. Sorry, excuse me, coldest temperature. Okay. So that's the reason I always say you should take the combination of altitude and latitude together, right? So don't consider only one factor. Okay, right, my friend. Okay, so two very important factors we have just taken it. Okay, so latitude we have taken it, and altitude also we have taken it. Just give me a minute, my friend. Right, my friend. So altitude as a factor we have seen, latitude as a factor we have seen, my friend. Two very important factors we have seen. Now let me take the case of what continentality, my friend. Right? Let me take the case of what continentality. So when I talk about continentality, simple, my friend. See, very important. I'm just going to give you a very important statement. Very simple statement, but very important statement. Somewhere you can write it. Right? Water maintains temperature, my friend. Water maintains temperature. Water maintains temperature. Now, what is the meaning of this water maintains temperature, if you ask me? Water will neither become too hot nor water will become too cold, my friend. Okay. Somewhere I understand always water maintains temperature. Water is not going to become so much hot, right? See, for example, when I talk about summer land will become extremely warmer and water will become comparatively colder, my friend. Even during daytime, it happens. Daytime also, what happens? Water, right? Say somewhere I understand water will maintain temperature. Daytime, land will become very warm. Nighttime, land will become very cold. But always water maintains temperature, my friend. Further, you can write fluctuation of temperature. Fluctuation of temperature is minimum in water. Fluctuation of temperature is minimum in water. Right. Now, if you ask me why, the reason is very simple, my friend. Normally, we say water has a high specific heat capacity. Somewhere you can write it. Why water maintains temperature, if you ask me. I would say, technically speaking, water has more specific heat capacity. Water has high specific heat capacity. You ask me, what is this specific heat capacity, my friend? What is the specific heat capacity? Technically, if you ask me, The amount of energy that is needed to increase the temperature of any substance by 1 degree centigrade. Simple, my friend. You take two vessels, two bowls. Am I right? Two vessels of water. Okay. Okay. I should say two vessels you take it. One vessel with full of water and another one empty vessel, my friend. Both you put it in the gas stove. You switch on the gas stove. Which vessel will become red hot in no time, if you ask me? Which will become extremely hot, if you ask me? Empty vessel, my friend. Right? Water will slowly, steadily, it will get warmed up. Okay. Now, okay, you have to raise the temperature of both the substance to the same degree. Okay. Assume that both are 60 degrees, 60 degree. Or okay, both are 100 degrees centigrade, my friend. Now you switch off the gas stove. Both the vessel, empty vessel is also 100 degree, water is also 100 degree. Now you switch off. Now comes the question, allow it to cool down, my friend. Which vessel will cool down faster, if you ask me? Again, it is empty vessel. So in between, what is the statement I would like to handle or means highlight is very simple. Water maintains temperature. Correct. It takes more amount of time for water to get heated up. Similarly, water will take more time to lose its heat. Right? That's the reason I said water maintains temperature, my friend. And one more thing, right? See, it depends on the latitude also. Water is not always warmer. Say, for example, how exactly water will behave, I'll tell you, my friend. If I'm just comparing if I'm just going for a comparison between a higher latitude and a lower latitude, between land and water, see, either I can just take it with the latitude or I can take it with water. Seasons, my friend. The same, right? Either you just take it with the latitude or you take it with the season, right? More or less it is going to match. And I'm just going to say, for example, compare land versus water, my friend. I'm just going to compare land and water. Okay. So I'm just going to compare land versus water. Right? A very important comparison. Very important comparison. My dear friends, if you're there in lower latitude. So what is this lower latitude, you know, right? When I talk about lower latitude that extends between 0 to 45 degree, normally you call them as what? Lower latitude. Or assume the same condition, I'm just taking it with summer, my friend. Okay. Right. Lower latitude, or you take the same condition with summer. Okay. Now, my dear friends, what exactly you experience? Right? Simply you apply the simple logic, right? If you're there in lower latitude, right? Water versus land. Which is going to be more warmer, my friend? Land is going to be warmer than water, my friend. Correct, lower latitude. Because I understand land immediately becomes hot. Water, it takes its own time in becoming, right, or means gathering what temperature. So in between what happens, water becomes comparatively colder than the adjoining land area. But the same concept, if I'm just applying for a higher latitudes, right, higher latitudes. So which latitude is called as higher latitude? 45 degree to 90 degree latitude, you call them as what? Higher latitude, or the same concept you applied during what? Winters, my friend. Okay. Now the reverse will happen. Land will become extremely cold. Comparatively, water become what? Warmer, my friend. Now here, the comparison is only between the land and water of the same latitude or same season. Do not compare, right, the waters of different latitude or land of different latitude. The comparison is only between land and water, right? So what is an idea, my friend? Lower latitudes, generally, water will be colder, land will be warmer. Higher latitude, it will be vice versa. Land will be colder and water will be warmer. Why? See, warm and cold, you should not treat it in absolute temperature, my friend. Always you should take it in what? Relative sense. Why I say take it in relative sense in the sense, warm and cold itself is a relative terminology. Warmer than, right, and colder than. Okay. Right. Never treat that, okay, 20 degrees centigrade means warm, 10 degrees centigrade means cold. No, don't take it that way. Okay. If I'm just comparing two locations, I'm just comparing, right? When I say I'll be comparing that one, I'll be saying that it is warmer than the another, right? Or I'll be saying that it is colder than the other, right? So whatever be the case, my friend. Okay. So somewhere I am just want to put a point that water maintains temperature. Okay. Okay. Right. So very important concept. Water maintains temperature. And my dear friends, plenty of places this concept you can apply it. I tell you, whichever land comes under the influence of water will behave like a water, and whichever water comes under the influence of land will behave like a land. Both way you can go for a comparison, but that comparison will do it at the later stage. Okay, right, my friend. So latitude I have given you, altitude I have given you, continentality I have given you, and now finally coming, or actually penultimately coming to this ocean currents, my friend. See, ocean currents plays a very important role in determining the climate of a particular place, my friend. Right? It plays a very important role in determining the climate of a particular place. Ocean currents plays a very important role. So you would have heard about phenomena like El Nino, La Nina, etc. Right? All these are nothing but what? Ocean currents, my friend. Phenomena of ocean currents. Okay? Nothing else. Right. Now, only thing is that I have to talk about ocean currents. So what is an ocean current? See, oceanography, we are going to talk about ocean currents. But what is a current, my friend? Anything which flows continuously, you call them as what? Current. Okay. So even in oceans, right, you have something like a river system that is flowing continuously. That's what you call them as a current, right? Now, my dear friends, I have just copied, that means I have just shown you some image, right? Ocean currents image. Okay. Maybe I'll just I'll go for some other. See, when I talk about ocean currents, my friend, only two types of currents you come across, right? You call them as what? Warm currents, and you call them as what? Cold currents. See, here itself they have given it. Okay. You call them as warm currents, you call them as what? Cold current. What is warm current and what is cold current? Just now I said, warmer than the adjoining water, you call them as warm current. Colder than the adjoining water, you call them as what? Cold current, my friend. Now, somewhere, all the currents which is flowing along the coast is going to influence the temperature of the coastline, my friend. Right? It is going to influence the temperature of the coastline. Right? Now, my dear friends, if that is the case, right, what I understand here, my friend. So, when I talk about ocean currents, right, I said only two types of currents are there. Either you have a warm current or you call them as what? Cold current, my friend. Okay. Now, here, okay, only two types of current. So, all that is marked red in color, right, they are warm currents. So forget about this blue, means black, my friend. All that is marked blue in color, right? They are cold currents, my friend. They are cold currents. All that is marked red in color, warm current, and all that is marked blue in color, they are cold currents. Okay? Right. Now, my dear friends, one pattern you find it. What is the pattern? I'll tell you. See, Ocean current itself is the concept of oceans. Okay, so my reference point should be ocean, my friend. You put yourself in the middle of any ocean, correct? Western side of the ocean will be having a warm current, and eastern side of the ocean you will be having a cold current. Any ocean you put yourself in, you will be finding the same phenomena. And only thing is that, see, it should not confuse you, but it is completely logical. And tell you what is west of ocean becomes east of land area, correct? So somewhere my reference, I'm just taking it with respect to the ocean, my friend. Okay. So normally I'm just giving you only one sentence, my friend. How do I remember? Somewhere you can remember west is warm. That's it. Only one sentence for examination you have to remember. So very easily you can remember where exactly, right, you'll be having this warm currents. Correct. So west is warm, my friend. Somewhere you can write it as what? West is warm. Right. Now somewhere west is warm means what? Western side of the ocean will have what? Right. Somewhere. You call them as what? West boundary current. And now about west boundary current will be a warm current. Right, will be a warm current, my friend, which runs along the boundary. Right, that's what I said, west is warm. But just to remember, you can write it as what? WW. And whenever I say west is warm, my friend, this is with respect to ocean, not with land. Am I right? Okay, west boundary current is always a warm current. That's the reason I said the west is warm, my friend. Okay, west boundary current is a warm current. And my dear friends, this reference is with respect to the ocean. Right? Very important, my friend. Okay, right. Now, ocean currents also I have just given you. And one more thing, wherever a place comes under the influence of warm current, right, you can write that also, right? Warm current will increase the temperature of a place, my friend. Right? On the other hand, when I talk about cold current will decrease the temperature of a particular place. Warm current will increase the temperature of a particular place, and cold current will decrease the temperature of a particular place. Right? Very important. Okay? Right. Okay. Right. So, what is the role of ocean currents? That also we have taken it. Correct? Right. Everything we have done, my friend. And finally, we are there in local factors. Right? Local factors. Right? Now, among the local factors, there are plenty of local factors. Right? If I just talk about, say, for example, right, cloud. Right? Cloud. Now, I have a question for you, my friend. You have to tell me what will be the role of the cloud. Will this cloud reduce the temperature or increase the temperature, my friend? Simple question. Will this cloud reduce the temperature or will the cloud increase the temperature? You say reduce the temperature, but let me say, my friend, cloud will do both. It depends on the time of the cloud formation. See, I'll tell you why. When I talk about cloud, okay. Say, for example, assume that I have a cloud. Okay. Now, my dear friends, only thing is that it depends when exactly you have a cloud. Okay, say, for example, cloud during daytime and cloud during nighttime will be behaving in a different fashion, my friend. Say, for example, I'm just comparing cloud during daytime versus cloud during nighttime, my friend. So normally what happens, my friend? If you have a cloud during daytime, okay, daytime, right, understanding says cloud has the ability to reflect what? Insolation, my friend. So it reflects insolation. If it reflects insolation, I understand it decreases the temperature, my friend. Daytime, it decreases the temperature. Okay. Cloud during the daytime will decrease the temperature. But the same cloud during night time, what will happen? This cloud, right? My friend, it will reflect back the terrestrial radiation, my friend. It will not allow the terrestrial radiation to escape. It reflects, right? It reflects terrestrial radiation, my friend. So when it reflects terrestrial radiation, what happens? Nighttime, the temperature will increase, my friend. Okay. So what happens? Cloud has a dual effectivity. Cloud during the daytime will decrease the temperature, and cloud during the nighttime will increase the temperature. That's the reason normally, my friend, if you have a cloud during the nighttime, you'll be finding little sultry, right? You'll be finding a little sultry, right? Sultry in the sense, right? You'll be slightly sweaty, right? You'll be feeling, right? You'll be sweating a lot, right? Somewhere you'll be finding it's more like warm nights, right? So the same cloud, if you have during the daytime, right? What happens? The cloud will reflect the insolation. Am I right? See, if you have a cloud throughout the day and night, the factor is different. I am talking about a cloud occupying a place only during the daytime or nighttime. Then it makes a difference. Correct? So cloud plays a dual role, my friend. Okay? So somewhere you can write cloud during daytime. I symbolically have told you, right? Cloud during daytime will reduce the temperature. Right? Will reduce the temperature. Whereas cloud during nighttime will increase the temperature. Cloud during nighttime will be increasing the temperature. Okay. Right. So what is the role of the cloud? Right. We have an idea. Cloud has a dual effectivity, my friend. Okay. Right. So what is the role of the cloud? Approximately we have an idea. And my dear friends, apart from cloud, when I talk about other factors, right? Water vapor, my friend. So when I talk about water vapor, see, water vapor also has a similar, say for example, property. When I talk about water vapor during daytime, my friend, water vapor will reduce the temperature because, right, it absorbs insulation, my friend. Right, it absorbs insulation. Right. Similarly, when I talk about water vapor during the night time, right, water vapor during the night time will water vapor during the night time will increase the temperature, my friend. Okay. So water vapor has a dual role, right? Night time, it increases temperature. Right? Why? Because when I talk about morning time, it absorbs, right, insolation. Right, in the upper reaches of atmosphere itself, it will absorb. Right, it will not allow the insolation to reach the surface of the earth. Am I right? See, only if it is allowing the insolation to reach the surface of the earth, right, surface of the earth gets heated up, only then it will be reflecting back this terrestrial radiation. Okay, their insolation itself will be absorbed. Here, it absorbs a terrestrial radiation. Absorbs terrestrial radiation. So by absorbing terrestrial radiation, it increases temperature. Correct? This is the role of what? Water vapor, my friend. And finally, when I talk about, say for example, after water vapor, when I talk about aerosols, my friend. Aerosols. Aerosols has only, right, aerosols has the ability to affect only what? The insolation, right? More is the aerosol, my friend, right? More is aerosol. Temperature is reduced. Only daytime, my friend. Only daytime. Because it scatters insolation. Right? Terrestrial radiation is not affected by aerosols, my friend. Okay. So somewhere all the local factors what we have taken it, they play a very important role. Cloud has a dual effectivity. Cloud during the daytime will decrease the temperature and during the night time will increase the temperature. Okay. Water vapor on the other hand, daytime will decrease the temperature, again nighttime will increase the temperature. I told you what exactly is the reason, right? So every factor we have seen in detail, my friend. We have seen in detail. Okay, right. So how this temperature varies from place to place, right? Everything we have seen in detail. So after completing horizontal distribution of atmospheric temperature, one small topic is there, my friend. One small topic is there. What is a small topic, right? When it comes to temperature, I call them as what? Temperature inversion, my friend. Temperature inversion. Right. What is temperature inversion? I'll tell you. See, you're there in troposphere. Okay. Temperature inversion, of course, all that what I'm just talking about, right? I am talking about the phenomena, what happens in troposphere, my friend. Right? I'm just talking about troposphere. The phenomena, what happens in troposphere. Okay. See, normally I know, my friend. Say, for example, if I'm just computing a graph, assume that I'm just computing a graph. Okay. See, one side it is with height. It is with height. Another side it is with temperature, my friend. Right? So one side it is height, another side it is with temperature. Okay. Now what happens, if you're there in troposphere, with increasing height, correct? With increasing height, temperature normally decreases. With increasing height, temperature normally decreases. Correct? You increase the height, temperature decreases. This is what you call them as what? Normal lapse rate. But however, under certain circumstances, what happens? With increasing height, not everywhere, my friend, under certain circumstances, with increasing height, the temperature also increases, not everywhere, only under certain circumstances. Okay. Very carefully look at this, only this particular line, my friend. Okay. Only this particular line. Okay. With increasing height, temperature also increases, right? This condition, we call them as what? Temperature inversion, my friend. We call them as what? Temperature inversion. Okay. This condition, we call them as what? Temperature inversion. Now, somewhere, another way of understanding what is this temperature inversion. See, normally you're there in troposphere. Somewhere I told you, right? You increase the height, temperature will decrease. Okay. It means what? Warm air mass will normally be there at the surface. Above this warm air mass, you will be having this cold air mass. Above this cold air mass, you will be having an air mass which is further colder than this. Okay. Right. If that is the case, my friend, I'll show you that how exactly this temperature inversion takes place. So normally if you ask me, and about the normal condition, my friend. See the normal condition? Normal condition is what? I'll be having a warm air mass. Above warm air mass, I'll be having a cooler air mass. Above this cooler air mass, what I'll be having is a cold air mass. But when I talk about temperature inversion is the condition where I'll be having a colder air mass near the surface, and above this colder air mass I'll be having one warm air mass, right? That's the reason I said, right, you increase the height, right, you increase the height, temperature also increases, then again it will start decreasing. But when I talk about on a temporary basis, my friend, you increase the height, temperature also increases. Okay, you increase the height, the temperature also increases. Okay, this is what you call them as what? Temperature inversion. Okay, right, my friend. So somewhere, what is temperature inversion? Approximately, we have an idea. Okay. Now, somewhere I'm just giving you an idea. Temperature inversion is that condition. When exactly temperature inversion will take place? The same thing, right? There's no same normal and temperature inversion condition. I'll redraw it, my friend, right? I'll redraw it. So, for example, assume that this is the surface, right? Surface, right? When I talk about temperature normal condition, my friend, I'll be having a warm air mass near the surface, correct? I'll be having warm air mass near the surface. And above this warm air mass, I'll be having what? One cold air mass. Okay. This is normal condition. Then what is temperature inversion condition? I'll be having vice versa, my friend. I'll be having cold air mass near the surface. And above this cold air mass, I'll be having what? Warm air mass. Right. So wherever in troposphere we have a condition which goes against this normal lapse rate, right? We call this condition as what? Temperature inversion. Somewhere I have just given you a clue, right, where this temperature inversion will take place. Temperature inversion will take place when the ground condition is what? Extremely cold, my friend. Okay. Now, somewhere, my friend, you yourself can tell me when all and where all ground condition will be cold. Any idea, my friend? Small topic, yes. When and where the ground condition will be cold, or the other way of asking, I'll tell you. Other way of asking the same question. When and where you may experience temperature inversion, my friend. I have given you a question, means I have given you a clue. Correct? What is the clue? Wherever ground condition is extremely cold, there all you may experience what? Temperature inversion. So throughout the year, my friend, give me one area or one region where you experience temperature inversion throughout the year. Ground condition extremely cold. My dear friends, polar region. Polar region throughout the year, ground condition will be extremely cold. So, polar region throughout the year, you may experience what? Temperature inversion. Or seasonally, if you ask me, which season you experience temperature inversion? Seasonally, winters is the season when you experience temperature inversion. Am I right? Right, my friends. So, somewhere, what is temperature inversion? Approximately, we have an idea. Correct? What occasion we have this temperature inversion, that also we have an idea, right? Now the write up I'll just give you tomorrow, my friend. So somewhere I'll just end the class today here at this moment. Okay, I'm just leaving you half an hour before. So tomorrow also we'll be having the same time, right? So I may not take for 4 hours, so I'll be taking only for what? 3.5 hours. Okay. So tomorrow, when I continue, I'll just give you the write up for this temperature inversion. Very important. Temperature inversion is important both for your prelims as well as mains. Okay, mains already once this question was asked in IFS examination, right? There is always a chance that it may be asked in what? Civil service examination also. Okay, right. So somewhere, let me conclude the class here at this moment. Right. So thank you. So if you have any doubts, maybe 5 minutes we can discuss some of the doubts if you have.
Thank you, sir.
Okay. Assuming that you don't have doubts, tomorrow we'll see you, my friends. Thank you and God bless you.